Yes, students, welcome to our video lecture. In the last lecture, we started students exercise 2, section E. We did sum number 1. Today, we are going to complete sum number 2, 3 and 4. Now students, all of you concentrate. The second sum reads as below. The data regarding the earnings in rupees of 50 rickshaw drivers during a certain day are as follows. Prepare a frequency distribution having one class as 220 to 239 and class length 20. 220 to 239. Now students, in this type of sums, the first step is to locate the highest and the lowest observations. So students, the highest observation students is, you can say, the minimum and maximum earning. Maximum earnings are 356 and the minimum earning is 200 rupees. Okay students, except is 356. Section E, sum number 2, we write here XH is 356 rupees and XL is 200 rupees. And one of the class is 220 to 239. Okay. So range of the data, is R is equal to XH minus XL, 356 minus 200, so 156 rupees. Class length is given as 20 and one of the class is given as 220 to 239. Okay students, this much must be crystal clear for all, and number of classes K is approximately range divided by class length, 156 divided by 20, so approximately 8. It is 7 point something, so approximately 8. And which result must be always satisfied, C into K greater than or equal to R. So if I take students 8 classes and class length is 20, so 8 into 20 is greater than or equal to 156, correct? 8 into 20 is 160. So how many classes students we need to make here? The answer is 8. Now, before starting students, before starting the frequency distribution, students, one must be giving a title. So let us give an appropriate title. The title is Inclusive Continuous Frequency Distribution of Daily Earnings of 40 rickshaw drivers. Inclusive frequency distribution of daily earnings of 40 rickshaw drivers. Yes, it is 40 only, I suppose. Yes, 40 rickshaw drivers of a particular city. The first column will be as usual number of classes or classes. Second column tally marks and third column frequency F5. So classes will be regarding daily earnings in rupees and F5 will be number of rickshaw drivers So if I prepare a table like this, F5, and this are tally marks, and this are classes. Now the first class must include minimum 200. So class number 1 will be 200 to 290, then 220 to 239. Check. This is one of the classes. 240 to 259, 260 to 279, 280 to 299, 300 to 390, 320 to 349, and 350 to 369. This will be our last classes. Oh, sorry, students. Here I should have written 330. Sorry, and this will be 340 to 350. Sorry. So the last class will be 340 to 359. Students, this is inclusive. So if I find boundary points, here it will be 199.5 to 219.5. So if you check, the class will become 20. Okay, students. Now, tally marks I have already done. Let us go on the corresponding frequencies. 4646, 4, 6, 4, 6, again 4, then 5, 6, 5, 5, 6, 5. So if I total this, then n will be 40. Now tally marks, students, all of you know how to do. The main part of sum is this. This is the main part of the sum. And this, students, we should never make mistake in this part, which is the most interesting one. Here by mistake, so I wrote here, students, 349, it should be 339, and then 340 to 359. 359 already includes 356. So title, range, number of classes, and the relation C into K greater than or equal to R. This must be, students, always followed whenever you prepare a continuous frequency distribution. Okay, students, let us do the next sum, third sum. Students, sum number 3. Let us read the question. The question reads as: information on monthly water consumption in units of 50 residents of a region is as under. Taking one of the classes as 25 to 30. 25 to 30 means definitely exclusive. Prepare exclusive continuous frequency distribution. In the sum only, students, they have told prepare exclusive continuous frequency distribution. Okay, once again, let us find range by taking XH and you can say XL. So the minimum value is 24 and the maximum value is 57. So XH, sum number 3 students, XH is 57 units and XL, students, is how much? We have written 24 units. So the the range of the data is 57 minus 24, so 33 units. This is, students, the range of the data. Okay. Now 25 to 30 is one of the class. A given class is 25 to 30. So class length C is equal to 5. Number of classes is approximately range divided by this class length. So approximately it is 6.5. Sorry, 6 point yes something. So let us take 7. So check 7 into 5 is 35, which is greater than or equal to 33. So this layout is very important, students. This layout here is 33 divided by 5, so 6.6. And I cannot take 6.6 classes, so I round it off to 7. So title, what will be the title? Exclusive continuous frequency distribution of monthly consumption of water. Exclusive. Continuous frequency distribution of monthly consumption of water. Monthly consumption of water in units of 50 residents of an area. Area of a particular city. So as usual, the first column will be classes, second column will be telemarks, and third column will be FI. Classes will be, students, you can say consumption of water units, of course, and FI will be number of residents. The lower limit means the lower observation is 24 and one of the classes is 25 to 30. So the first class will be 20 to 25, then 25 to 30, then 30 to 35, 35 to 40, 40 to 45, 45 to 50, 50 to 55, and last class will be 55 to 60. This will be our table. This time I will increase the breadth. Now tally marks, all of you know. So I am telling the frequency 21097. 21097. Then 10534. And of course the total will be 50. Because the number of residents are how many? 50. So now this type of sum, students, are very easy. Here it is not 7.5, it is 7 into 535, which is greater than 33. The relation C into K greater than or equal to R, students, must be always followed. Okay, let us do, students, sum number 4. Yes, students. Now we are doing sum number 4. Section E, sum number 4. Students, the sum reads as below. The data obtained by inquiring price of an item at 50 different shops are as under. Prepare a frequency distribution having the last class as 85 to 90. Okay, the distribution must end at 85 to 90. So here, students, the minimum observation is 62, and students, the maximum here you can say the minimum observation is 62, and the maximum observation must be within the frame of 90, because our last class is, students, 85 to 90. Okay, students, so let us check the highest observation is how much. I think the maximum observation is, students, 86. Yes, we don't have any observation which is greater than 86. The minimum is 62. So XH is 86 and XL is 62. Sorry, students, this is 62. And the data is given, students, regarding what? The data obtained by price of an item in 50 different shops. Okay, so the data is regarding rupees, isn't it? The data obtained by inquiry price of an item in 50 different shops. Correct. So the data is in rupees only here. They are not given. The price generally is in rupees. So 86 rupees and 62 rupees. So range is 86 minus 62. So 24 rupees. Here the last class is 85 to 90. Class length is 5. So number of classes is range divided by class length. 24 by 5. So approximately, students, we will have how many classes here? 5. Approximately, students, we will have here 5 classes. But if I take 5 into 5, then here it is 25, and 25 is greater than 24. Okay, students, but let us check here. The point is that the minimum weight is 62. So if I take even 5 class, it is correct. Even if I take 6 class, then also it is correct, because they have told that last class must be from 85 to 90. Okay, so let us give the title. It is the frequency distribution of exclusive continuous frequency distribution of price of an item at 50 different shops. Exclusive continuous frequency distribution of price of an item at 50 different shops of a particular area. Okay, students, now here I am going to start with the last class. So let us write here classes, telemarks, and F5. Classes is nothing but price of an item. Telemarks, of course, frequency is number of different shops. Okay, the last class is 85 to 90. Above class will be 80 to 85, 75 to 80, 70 to 75, 65 to 70, and 60 to 65. As such, according to the formula, we should have minimum 5 classes. If I take 6 classes, it is not wrong, because they have told that last class must be, you can say 85 to 90. So if I take 6 class and the class length is 5, then 6 into 5, 3 and 3, 6, and range is 24, correct? Okay, students. So 6 into 5, 30 is also greater than or equal to 24. Even if I have taken 5 classes, then also it is correct. But since in the sum they have given that the last class must be 85 to 90, that is why, students, we have taken 6 classes. So if I prepare the table and make a box, then this is our final table. And if I go with the telemarks and frequency, 5, 11, 11, 5, 3 times 11, then 7 and 5, and total is nothing but 50, because the number of shops under consideration, students, are how many? 50. So this is one of the most interesting concept, because in exclusive, upper limit of a class is included in the next class. In exclusive, upper limit of a class is, students, always included in the next class. So now, students, our section E we have done questions 1, 2, 3, 4, 5 and 6. The remaining questions, students, are of a different concept. Now, students, I am coming back to exercise 2.1, and I know that in exercise 2.1 we have to, you can say, do sum number 6 and sum number 7. The sixth sum is obtain an inclusive continuous frequency distribution from the following data, and the seventh sum is obtain an exclusive continuous frequency distribution from the following data. So we are coming back to, students, exercise 2.1, sum number 6 and sum number 7. Now, students, before starting the sum, if you carefully observe, here it is given as less than rate and cumulative frequency distribution. I am talking especially of the 7th sum. Check 7th sum. Obtain an exclusive continuous frequency distribution. Now, students, if you recall, there are 2 types of cumulative frequency distribution. One is less than time and other is more than time. Yes or no? So, in less than time, we use upper boundary points, and in more than time, students, we use lower boundary points. This much theory all of you must perfectly remember as well as understand. These theories are very, very important. That in less than time, we use use upper boundary points. And if you remember, we used to start a value before. So in short, all boundary points are covered. Yes or no? And for the first frequency, we used to write 0. So all of you carefully observe in sum number 7 students, we are given in sum number 7 students, we are given that obtain an exclusive continuous frequency distribution. And in the sum of cumulative frequency, you check in the less than type cumulative frequency distribution, we start with minimum frequency and we end at maximum frequency. So if you carefully check the previous sums where we have found out students cumulative frequency distribution, you clearly understand. Generally, there are two types of cumulative frequency distribution students, less than 10 and more than 10. This is okay. In less than 10, we use upper boundary points, but we used to start with the value before and write its cumulative frequency 0, you check. So in our sum, that value for which the cumulative frequency 0 is 30, means 30 becomes the lower limit of first class. Then all the upper boundary point starts. Here it is 35, 40, 45, 50, 55, 60, 65 and 70. So in less than 10 we use upper boundary points and we used to start with the value before that. So students, pay attention. So I am writing the 7th sum, exercise 2.1, 7th sum. The title is the original exclusive continuous frequency distribution of weights in kg. It is given from given less than type cumulative frequency distribution is as below. This title is must. If this is a 3-mark sum, 1 mark students will be allotted for title. If this is a sum of 3 mark students, 1 mark will be allotted for title. And here we will make only 2 columns, and the columns are classes and F5. So check, the lower limit of the first class is 30. So the first class will be 30 to 35, then 35 to 40, 40 to 45, 45 to 50, 50 to 55, 55 to 60, then 60 to 65 and 65 to 70. So what is the concept students which I am trying to explain? In less than 10 we use upper boundary points. So upper boundary point starts from 35, 40, 45, 50, 55, 60, 65, 70, but we used to start with the value before and its cumulative frequency was written 0. So that value when cumulative frequency is 0 becomes the lower limit of first class. So the classes starts from 30 to 35, 35 to 40, 40 to 45, 45 to 50, 50 to 55 because it is exclusive. In exclusive continuous frequency distribution, upper limit of a class and lower limit of next class are exactly same. So now students, while writing frequency, pay attention. While writing frequency, it is very simple. Subtract the second cumulative frequency from the first. So 17 minus 0. So 17. Subtract 25 minus 17. So 8. Then 40 minus 25, so 15, 48 minus 40, so 8, then 54 minus 48, so 6, then 57 minus 54, so 3, 59 minus 57, so 2, and 60 minus 59, so 1. And if I total this will come up to be 60. Check. 17 plus 8, 25 plus 15, 40 plus 8, 48 plus 6, 54 plus 3, 57 plus 2, 59, and 1, 60. So the hint is, where cumulative frequency is 0, that value becomes lower limit of the first class. And where the cumulative frequency is maximum, that becomes upper limit of the last class. So upper limit of the last class is 70 and the lower limit of the first class is 30. This is the main point. And if I complete the box, this is our final frequency distribution, of which cumulative frequency distribution is already given in the table. Classes students, these classes are definitely for weights. These classes are for weights. And students, Fi will be, you can say, definitely less than weight, but this is weight of what is not given. So students, we cannot specify what is given as Fi. These are weights of person, these are weights of an item, these are weights of an instrument. Weights of what is not specified, but in question they have given that less than is in terms of weight. So classes has been its weight. That students we have already written. So from less than 10 cumulative frequency distribution students, we have tried to obtain an original frequency distribution. And remember, in less than 10 we use upper boundary points. For exclusive boundary points and class limits are same, but in the cumulative frequency distribution we check, we start with the value before, and for that value the cumulative frequency is written 0. So the value for which cumulative frequency is written 0 becomes lower limit of first class, and the value of cumulative frequency which is maximum, cumulative frequency is maximum at 60, and that